Hello guys, welcome to the next class of limits. In the previous class, we have discussed till algebra of limits, and in this class, we'll discuss how do we solve the limits which are of indeterminate form of some specific types. First one is the algebraic limits. In algebraic limits, we'll discuss those problems will have polynomial by polynomial. So first of those problem is limit x tend to 1 x square minus 3x plus 2 by x square minus 5x plus 4. First of all, like we discussed in the previous class, whenever you have a limit problem, first thing you will do is just put x equal to 1 here and see what form is this. When you put x equal to 1 here, you get 0 by 0 form. You can see that when you put x as 1, you get 0 in the numerator, 0 in the denominator. So this is indeterminate form, so we'll have to solve now. So how do we solve this thing? See, you will see that if by putting x equal to 1, this thing became 0, that means 1 will be the root of this polynomial. So we can find the other root and factorize. We get x minus 1, x minus 2. Similarly, divide by x minus 1, x minus 4. Now, when we have limit x tend to 1, so like I told you here, x is not equal to 1, x is close to 1. So this thing is not equal to 0. X minus 1 is not equal to 0. It is close to 0. So if a number is close to 0, we can cancel it out. 0 by 0 we cannot cancel. But if a number is close to 0, then we can cancel. So we make use of this limit thing and cancel it out. So what we are left with only x minus 2 by x minus 4. Here we put x equal to 1. So you get 1 minus 2 over 1 minus 4, which is 1 by 3. So this is your final answer. Okay, let us go to the next problem. We have limit x tend to 1 x square minus 3x plus 2 by x minus 1. Now, same thing here. When you put x equal to 1 here, we get 0. X equal to 1 here, we get 0. So, 0 by 0 form. So, you can give it a try. Okay, let us start discussion now. We have limit x tend to 1, this thing. Again, 1 is a root here, you get x minus 1, x minus 2. Divide by x minus 1. So x minus 1 get cancelled out, you get x minus 2, put x as 1 here, you get minus 1. So limit here is minus 1. This is the answer. Now, just to see the geometry of this function, if I take this as f of x and try to understand what is this function, you will see 1 will not be in the domain of the function. So the domain will be all real number except 1. And except 1, we can cancel out x minus 1, like this here. So fx will just come out to be x minus 2. But with the domain, all real number except 1. So if you try to plot this thing, this is how the graph will look like. So you say fx is x minus 2. So y equal to x minus 2 with the whole at 1. And what is the geometrical meaning of limit here? You will see the value at 1 would have been minus 1. If there was no whole, then the value at 1 would have been minus 1. Right now, 1 is not in the domain. So we see when x approaches 1, what is the value of the function approaching to? You can see either you come from left side or right side. When x is around 1, value is approaching minus 1. So for these kind of function which abruptly are not defined at a particular point, we can use limits to find its approximate value. What would have been the value for that point if the function was defined? Or what is the value in the neighborhood of that point? So you get the idea, okay, that point is not in the domain, but what is the value of function around that? So that is minus 1 here, as you can see. Okay, guys, moving forward. Next, we have in algebraic limits only, we have two particular forms. So limit x tend to a x power n minus a power n by x minus a. This limit will be equal to n into a power n minus 1. Limit x tend to a x power n minus a power n by x minus a will be equal to n into a power n minus 1. How do we prove this thing? We can prove this thing easily with the help of LH rule, which we will discuss later on, or we can prove this thing using GP also, geometric progression, but we don't need to go into that much of detail. We'll just can see the proof later with the help of LH rule. Now we'll just use it to solve. Next, we have now the important modification here. This modification thing will be there for each and every of the formula later also. What do you see here, guys? In place of x, there could be f of x also. So now we have f of x power n minus f of a power n divided by f of x minus f of a. So in place of x, we have f of x. In place of a, we have f of a. There also same thing will work. It will be n into f of a power n minus 1, and proof will also be same. With the help of LH rule, we can prove this also easily. For now, you can just use it directly. So remember just two things here. You can note down in your notes also. Limit x tend to a x power n minus a power n by x minus a is n into a power n minus 1, and limit x tend to a fx power n minus f of a power n by fx minus f of a is n into f of a power n minus 1. Okay, let us do some problems on this. So first problem, guys, you can try. Limit x tend to 2, x power 4 minus 2 power 4 by x minus 2. You can pause and give it a try. Okay, let us start discussion now. This will directly be equal to 32. You can see here just n is 4 and a is 2. If you use the formula, get 4 into 2 power 4 minus 1, which will be 32. Okay, next problem. We have limit x tend to a x power 7 minus a power 7 by x power 4 minus a power 4. Give it a try, guys, then we'll discuss. Let us start discussion now. See, in this problem, we have x power 7 minus a power 7, x power 4 minus a power 4. What I'll do is I'll split them and then multiply divided by x minus a. So we can use the formula on this thing separately and this thing separately. So this will become 7a power 6. This will become in the denominator 4a cube. When you divide them, you get 7 by 4a cube. I hope it is clear, guys. Next problem. Okay. Limit x tend to 1, 3x plus 5 power 4 minus 8 power 4 by 3x minus 3. Give it a try. Let us start discussion now. What we have here is this is that fx problem. In place of x, we have 3x plus 5. So in the denominator also, you will add 5 and subtract 5. So it will become 3x plus 5 power 4 minus 8 power 4 by 3x plus 5 minus 8. So fx power n minus f of a power n by f of x minus f of a. See, if you take f of x as 3x plus 5, when you put x as 1, f of 1 will be 8. So a is basically 1 here, and f of 1 is 8. So same formula, n into f of a power n minus 1, you get 2048. Next problem. Now, I hope you see this on the bottom of the screen. Limit x tend to 1 x power k summation k1 to 2007 minus 2007 divided by x minus 1. Give it a try, guys, and we'll start discussion. Let us start now. What do we do here? This summation k1 to 2007 x bar k. We can write this thing as x bar 1, x bar 2, x bar 3 up to x bar 2007. This 2007 also break as 1 plus 1 plus 1 and so on. Divide by x minus 1. Now you split them all. X minus 1 by x minus 1, x square minus 1 by x minus 1, x cube minus 1 by x minus 1 up to x bar 2007 minus 1 by x minus 1. Okay, 1 square, 1 cube, 1 4 are 1 only. So in all of them we can use the formula now. With a value will be 1 and n will be 1, 2, 3, 4 up to 2007. So finally, for the values come out to be 1, 2, 3 up to 2007. You can just add this thing using the formula n into n plus 1 by 2. Sum of first and natural numbers. So you get 2007 into 2008 divided by 2. I hope it is clear, guys. Next problem. Now this one is interesting. This thing limit x tend to 3, x square minus cx plus 6 by x square minus 7x plus 12. If L is finite, find the value of C and L. The same L here. This unknown C you have to find out, then the limit you have to find out. So give it a try, guys, then we'll start discussion. Okay, let us start now. So the final answer is C5, L minus 1. Those who haven't got, see this thing. First of all, like we discussed, you put x value as 3 and see what form is this. When you put x as 3, you get numerator to be 9 plus 6 minus 3c divided by 0. Now, if 9 plus 6 minus 3c is not equal to 0, it will become something finite divided by 0, which will be infinity. But L cannot be infinity. This thing L is finite. So that is only possible if it is an indeterminate form. That means 9 plus 6 minus 3c has to be 0. So if denominator is 0, numerator has to be 0 to make it indeterminate form. So from there c will be 5, and if c is 5, you can factorize this thing then. So if c is 5, will become x minus 3, x minus 2. Denominator is anyhow x minus 3, x minus 4. X minus 3 will get cancelled out. We put x as 3 here. You get 3 minus 2 by 3 minus 4, which will be minus 1. So c will be 5, L will be minus 1. I hope it is clear, guys. Next problem. Now this next one is a bit typical problem. You can give it a try, guys. Alpha and beta are two distinct real roots of the equation ax cubed plus x minus 1 minus a equal to 0. A is not equal to minus 1 or 0. Alpha, beta are not equal to 1. Then x tends to 1 by alpha, 1 plus a x cubed minus x square minus a by 1 minus alpha x into x minus 1. So this limit you have to solve. Give it a try, then we'll start discussion. Okay, let us start now. See, what do you see first of all here? The given cubic equation, x cubed plus x minus 1 minus a equal to 0. Two roots are alpha and beta. For the third root, if you put x equal to 1 here, you will see it will satisfy. If you put x equal to 1, you get a plus 1 minus 1 minus a, which will be equal to 0. So we get all three roots, alpha, beta, and 1. Now, if you see the given cubic in the limit, here the constant is minus 1 minus a, here the coefficient of x cube is 1 plus a. So what you do is, if you just replace x by 1 by x, you get this cubic. You get 1 plus a x cube. Basically replace x by 1 by x and then take LCM. and negative sign you will rearrange. You get 1 plus a x cube minus x square minus a equal to 0. So if the roots of the previous equation was alpha beta 1, now it will be 1 by alpha 1 by beta 1. Okay, now if the roots are 1 by alpha 1 by beta and 1, we can factorize this cubic equation as x minus 1 by alpha, x minus 1 by beta into x minus 1, and the leading coefficient, basically the coefficient of x cube, is 1 plus a here, so you have to multiply 1 plus a right side also. This factorization, if you don't know, we'll discuss in quadratic equations chapter. For now, you can see this is how it works. So numerator, you replace by this thing, you get 1 plus a, x minus 1 by alpha, x minus 1 by beta, x minus 1. In the denominator, from here, if I take minus alpha common, we get minus alpha outside, x minus 1 by alpha, x minus 1. So x minus 1 get cancelled out, x minus 1 by alpha get cancelled out. Whatever left, put x as 1 by alpha, get 1 plus a. This minus alpha will be as it is, and this will become 1 by alpha minus 1 by beta. Okay, if you just that is this, you can leave here also. And if you want to just simplify, take LCM here, you get 1 plus a alpha minus beta by alpha into alpha beta. Now the product of the roots of this cubic, the roots are alpha beta 1, product of the roots, if you know, it's minus d upon a. Okay, again I'm just simplifying, you can leave it here also. So product of roots will come out to be alpha beta 1, which will be 1 plus a by a. So you can put alpha beta as 1 plus a by a here. So this 1 plus a will get cancelled out. You'll just get a by alpha, alpha minus beta. That also is the final answer. Okay, I hope this is clear, guys. This is a good problem. Let us go to the next now. Now, next is very, very important, trigonometric limits. So first we'll discuss few forms directly, and then we'll do the problems. First of all, in the trigonometric limits, we have limit x tend to 0, sin x by x is equal to 1. Now, again, how do we get this thing? Two ways you can prove this thing, using LH rule, and second, we can use expansions also. Both of them we'll discuss in detail later, so you just leave the proof for later and see this thing. This is limit x tend to 0, sin x by x equal to 1. Similarly, limit x tend to 0, sin inverse by x is also 1. Sin inverse x by x is also 1. Limit x tend to 0, tan x by x is also 1. Limit x tend to 0, tan inverse x by x is also 1. Limit x tend to 0, 1 minus cos x by x square is 1 by 2. Okay, all these are very, very important formulae. Do make a note of them. And the modification of all them. So in place of x, there would be f of x, something else. Then in the denominator also should be f of x only. And whatever the limit is, like here limit is x tend to a. So if you put a here, f of a should be 0. So remember, thing inside sign should be 0 and same thing should be there in the denominator. So sin fx by fx will also be 1 if f of a is 0. And same you can do for all the remaining formulae also. So remember guys, this is very, very, very important. Next. Now a few more, you can say advanced points here. Now this limit x tend to 0 positive, sin x less than tan x. See what happens here. When we see that like at 0 they all are almost 0. Like at 0 they all are 0. But when x is slightly more than 0, they are very close to each other. But in reality, sin x will be less than x, which will be less than tan x. And when x is slightly less than 0, then the order will reverse. Then tan x will be less than x, which will be less than sin x. Okay, and you can see this thing graphically also. I'll show you. If we have this graph, you see this is a line y equal to x. Sin x will be like below here. Tan x will be above this line. So at 0 they all intersect, but after 0 Sine will be less than x and tan will be more than x. And same thing will happen in the reverse order in negative. Here, sin x will be more than x and tan x will be less than x. So do remember this thing, guys. This is very, very important. Now we have limit x tend to 0, step of sin x by x. Limit x tend to 0, step of sin x by x. So what happened here is, if I say x is 0 positive, you see sin x by x is almost 1, but in reality it is slightly less than 1. In reality, it will be slightly less than 1 because you see sin x is less than x. So this thing will be 1 negative. This thing will be 1 negative. If they were just asking sin x by x limit, we say 1. I told you final answer is just the exact number. But if we have to use this intermediate value at some other function is like just step outside, no? So we use the intermediate value. So it is not just 1 we put here. We see if it is 1 positive or 1 negative. In this case, it is 1 negative, and when you put that inside step, we get 0. So limit x tend to 0, sin x by x step is equal to 0. Now you might think that, okay, that is for 0 positive. What happened in 0 negative? In 0 negative, the sin x is more than x. The thing is, sin x is more than x just because of the sign negative. Magnitude wise, still x will be more than sin x. For example, say sin x is minus 0.1 and x is minus 0.2. Just taking a hypothetical case. You see sin x is more than x. But when you cancel out the negative sign, then x is more than sin x again. Because x will still have more magnitude. So if you take 0 negative also, step will be, this value will be 1 negative. Step will again be 0. So this is very, very important point, guys. So limit x tend to 0, sin x by x step is 0 because sin x by x is 1 negative. Now what about sin inverse x by x? You see sin inverse x is a mirror image of the line in the line y equal to x. Sin inverse function is mirror image in the line y equal to x. So if sin x is less than x, sin inverse x will be more than x using the inverse property. So then this value will be 1 positive and step of 1 positive will be 1. Now same thing here, tan x by x will be 1 positive because tan x is more than x, so 1 positive step will be 1. And if tan x is more than x, tan inverse x will be less than x, so this will be 1 negative, so it will be 0. Now this, we have limit x tend to 0, sin x by x, then we have step. So see what happened here is, what is the difference here and here? Here the limit is inside step. That means first we take the limit, then we put it inside step. And when we take the limit on this thing, then we say this value is exactly 1. Here limit is outside. So we use the intermediate value because we are not taking limit on sin x by x. We're taking limit on step of sin x by x. But here we're taking limit on sin x by x. So we evaluate the limit, that will come out to be 1. Which when you put inside step, that will be 1 only. So do remember this intermediate value theorem. If the limit is outside, we use intermediate value. But if limit is inside, we evaluate the limit first, which will be 1. So that will be true for all of them. And last, one bonus point here, limit x tend to 0, sin x into tan x by x square step. So what do we have here is, now we see sin x by x was 1 negative, tan x by x was 1 positive. If you multiply these two, we cannot guarantee what if it will be 1 positive or 1 negative. One number is more than 1, one is less than 1. When you multiply, we cannot say anything directly. But in this case, it will be 1 positive only. So step will be 1. How we'll discuss the proof here. See, sin x, I'll use tan half angle, you get 2 tan x by 2, 1 plus tan square x by 2. Tan x, use the half angle, you get 2 tan x by 2. by 1 minus tan square x by 2 and 1 by x square as it is. Now this tan x by 2, we can use tan x by 2 by this x square and these 2's we take here. So become tan x by 2 by x by 2 whole square. And we discuss tan x by x is more than 1, so it will be 1 positive. We are left with only this part. This will be 1 by 1 minus tan power 4 x by 2. You know, tan power 4 will be slightly more than 0. Now, if from 1 you subtract a number which is slightly more than 0, so the denominator will be slightly less than 0. Sorry, denominator will be slightly less than 1. So if denominator is 1 negative, we can say 1 by 1 negative will become 1 positive. So the first part is 1 positive, second part is 1 positive into 1 positive will be 1 positive. So we can conclude this thing is 1 positive, so step will be 1. Okay, I hope it is clear, guys. These are the formulae for trigonometric limits. Now we'll see the problems. Let us start with the first problem. Limit x tend to 0, sine of 4x by x. Give it a try, guys, then we'll start discussion. Let us start. We have sine 4x by x. You know, if we have 4x inside sine, in that denominator also should be 4x only. So we multiply divide by 4. Now if x tend to 0, 4x will be 0. Like I told you, whatever is inside sine, that thing should be 0 also. Then only we can use the formula. So sine 4x by 4x will be 1 into 4. So answer will be 4. I hope it is clear, guys. Next problem. What do we have here? We have limit x tend to infinity e power x into sine of 4 times e power minus x. Give it a try, then we'll start discussion. Let us start now. The answer here is 4. Those who haven't got, see this thing. We can write this e power x in the denominator, it will become e power minus x. Inside sine we have 4 e power minus x, so multiply divided by 4. Again, when you put x as infinity, 4 e power minus x will become 0. Because e power minus infinity is 0. So sine fx by fx tend to 0 will be 1 into 4, so answer will be 4 again. I hope it is clear, guys. Next problem. We have limit x tend to infinity sine of 3 by 4x divided by tan of 4 by 3x. Give it a try, guys, then we'll start discussion. Let us start now. We have limit x tend to infinity. See, sine of 3 by 4x, so multiply divide by 3 by 4x. Tan 4 by 3x, so multiply divide by 4 by 3x. And when x tend to infinity, this will be 0, this will also be 0. So directly we can say this will be 1, this will also be 1. We're left with 3 by 4x and 3x by 4. So the x and x will get cancelled out here, you get 9 by 16. So the final answer is 9 by 16. Next. Next we have limit x tend to infinity x into cos pi by 6x into sine pi by 6x. Give it a try, guys, then we'll start discussion. Let's start now. The answer will be pi by 6. See how we get this thing. Cos pi by 6x, you just keep as it is. Because when I put x infinity here, it will become pi by infinity, which will be 0, and cos 0 is 1. For sine thing, I'll take this x in the denominator. So the x will become 1 by x in the denominator, multiply divided by pi by 6. Now we get sine fx by fx. And when you put x infinity, this thing will be 0 also. So this limit will be 1. This is 1. The answer will just be pi by 6. I hope it is clear, guys. Next problem. Next problem, we have limit x tends to infinity sine x by x. So what will be the answer here according to you? The answer here will be 0. How 0? See, when I put x infinity here, we get sine infinity by infinity. Now, sine of infinity, sine of anything will just lie between -1 to 1. So this is not an infinite number. We say this is a finite number, but -1 to 1. And when you divide that by infinity, it will be 0 only. It is not even an indeterminate form. It is just a finite by infinity, which is always 0. Okay, next. Next problem, limit x tend to 2 sine of x square minus 5x plus 6 by x square minus 7x plus 12. Give it a try. Let's start discussion now. The answer here will be 0. Because when you put x as 2 here, you get sine of 0, which will be 0 divided by 2. So 0 by 2 will just be 0. It is again not indeterminate form. Always check it before you start solving a problem. Next. Limit x tend to 3 sine of x square minus 5x plus 6 by x square minus 7x plus 12. Here, try to solve. Let's start discussion now. The answer for this problem is -1. See how? You see, when you put x as 3, it will be 0 by 0 form. So what we'll do here is this thing we factorize x minus 3, x minus 2. Denominator we factorize x minus 2, sorry, x minus 3, x minus 4. But you want x minus 3 only, so keep x minus 4 outside, and we need x minus 2 also. So multiply, divide by x minus 2. Now sine of fx by fx will be 1, and fx do tend to 0. And this thing x minus 2 over x minus 4, just put x as 3 here. We get 3 minus 2 by 3 minus 4, so this will become -1. So 1 into -1, final answer is -1. I hope it is clear, guys. Next problem. Next we have limit x tend to 0, step of sin x by x plus step of 2 tan x by x plus step of 3 sin x by x plus step of 4 tan x by x up to step of 10 tan x by x. Give it a try, guys. This is a good problem. Let us start discussion. The answer for this problem is 50. See how? Like we discussed, sin x by x will be 1 negative, so step of that will be 0. Tan x by x will be 1 positive. If you multiply by 2, it will become 2 positive, and step will be 2. Okay, I hope it makes sense. When you multiply 2 with a number which is slightly more than 1, the product will be slightly more than 2. So step will be 2. Sin x by x again less than 1, slightly less than 1. When you multiply by 3, you get slightly less than 3. So step here will be 2. Next, for tan x by x, again 1 positive into 4, you get 4 positive, step will be 4. This is same pattern we keep on repeating. So first is 0, then 2, 2, then 4, 4, then 6, 6, then 8, 8. Last will be 10 for this tan x thing. When you add, then you get answer to be 50. Okay, guys, next problem. Now try this. Limit x tend to 1. This is again step. Step of 2 sin x minus 1 by x minus 1. So the answer here will be 1. Because again, when x tend to 1, x minus 1 will tend to 0. So we can say this thing will be 1 negative, multiply by 2, it will become 2 negative. So step of that will be 1. Next problem. Now this is a very good problem. Next one. What do we have here? We have limit x tend to 0 positive, fractional part of sine x minus x. Limit x tend to 0 positive, fractional part of sine x minus x. Give it a try. Let us start discussion. When x tend to 0 positive, you see, we discussed that x will be more than sine x. So sine x minus x will become slightly less than 0. So it will be 0 negative. And fractional part of 0 negative is 1. You see, fractional part of 0 negative we can write as 0 negative minus step of 0 negative. You know the formula, no? Fractional part of x is x minus step x. So 0 negative is just 0 negative, but step of 0 negative will become minus 1. So minus minus become plus 1. So 0 negative plus 1. So it will be almost 1 negative, but we can say 1 negative finally we see as 1 only. So this is a good conceptual problem, guys. Make sure you get to understand this thing. Next. Okay, now this is again a very good problem. Fx is x plus 1 when x is greater than or equal to 0 and 2 plus x square when x is less than 0. To find limit x tend to 0, f of step of x minus tan x. Again, this is a step here. F of step of x minus tan x. Give it a try, guys, then we'll start discussion. Let's start now. The final answer here is limit does not exist. See how? When you take 0 positive, x tend to 0 positive, you know x will be less than tan x. So x minus tan x will be 0 negative. And when you put 0 negative inside step, it will exactly minus 1. Now there will be no positive or negative here, like it's not tending to anything. Step of 0 negative is straight minus 1. So you get f of minus 1, and f of minus 1 you can find from here, it will be 3. So RHL, the right hand limit, 0 positive is 3. Next, 0 negative. When x is slightly less than 0, you know x is more than tan x now, so x minus tan x will be 0 positive. So the step value here will be 0. Step of 0 positive will now be just exactly 0. So f of 0 we can find from here, that will be 1. So see, RHL is 3, LHL is 1, so limit does not exist. Good problem, guys. Next one. Now next we have that LH rule. L L'Hopital's rule, like we write it as L Hospital's rule, but it's L'Hopital rule, or in short form you can use LH rule. Okay, so I'll be using LH rule. What does LH rule says? If we have limit x tend to a fx by gx, and if it is 0 by 0 or infinity by infinity, it can be used on only these two forms, 0 by 0 or infinity by infinity. Then what we can do is we can differentiate the numerator, differentiate the denominator separately, independently. We're not using u by v rule. So we differentiate numerator separately, get f dash x, denominator separately, get g dash x, and take limit on that thing. So this limit is equal to this limit also. Again, if it is 0 by 0, infinity by infinity form, again we can do the differentiation thing. Okay, so with the help of this, we can prove the previous formula also and solve more problems. But usually we'll solve it for simple problems only. The complex problem, if you use LH rule, they'll become more complex. So we'll avoid that. We'll just use it for some simple things. Like this first one, I gave you this one in the trigonometric limits formulae. Limit x tend to 0, 1 minus cos x by x square. You see it is 0 by 0 form, so we use LH rule. So we differentiate the numerator, we get sin x. We differentiate denominator, we get x square. Sorry, differentiate the denominator, we get 2x. Now sin x by x, when x tend to 0 will be 1 and 2 will be outside, you get 1 by 2. So this is how we get that thing. So all the formulae which we proved, which we have discussed for the algebraic also and all the trigonometric limits formulae before the step thing, everything can prove using LH rule. Next, some miscellaneous problems like this: limit x tend to infinity, log x by x. Give it a try. Let's start discussion. You see, when I put x as infinity, you get log infinity, which is infinity, divide by infinity. So infinity by infinity form, use LH rule, differentiate the numerator, you get 1 by x, denominator, you get 1. And when you put x infinity here, you get 1 by infinity, which will just be 0. So directly we get here 0. Okay, next. Next we have exponential limits. See, there are just 4 forms here. First of all, we'll discuss them quickly. Limit x tend to 0, e power x minus 1 by x will be 1. A power x minus 1 by x will be ln a, where a is some positive real number except 1. A should be greater than 0 and not equal to 1. Usual that we have on the exponential function. Again, if you want to prove this thing, you can prove it easily with the help of LH rule also. Or we can prove with the help of expansions also, which we'll discuss later. Right now you can see directly. So limit x tend to 0, e power x minus 1 by x is 1. Limit x tend to 0, a power x minus 1 by x is ln a. And same we can modify, replace x by f of x. So this will still work. The condition that if limit x tend to alpha, then f of alpha should be 0. So we can replace x by f of x with the condition that f of alpha should be 0 if x tend to alpha. So e power fx minus 1 by fx will also be 1. A power fx minus 1 by fx will also be ln a. Condition is f of alpha should be tending to 0. Okay, you can note down this formula, guys. Then let us try these problems now. So first problem, you can see limit x tend to 0, 5 power x minus 1 by x. Limit x tend to 0, 5 power x minus 1 by x. Directly you can say answer will be ln 5. Straight formula, this one. Okay, let us see some more typical problems now. The second one. We have limit x tend to 0, sin x over e power 2x minus 1. Give it a try, guys. Let us start discussion. The answer will be 1 by 2. Those who could not solve, see guys. See, we have sin x. To solve sin x, we need 2x in the denominator, so we multiply divide by x. So sin x by x will be 1. To solve e power 2x minus 1, we need 2x in the denominator, so we multiply divide by 2 also. X already there. So now e power 2x minus 1 by 2x will also be 1. When x tend to 0, 2x will automatically be tending to 0. So this is 1, this is 1, this is 1 by 2. So we get this as 1 by 2. Okay, so we use this e power fx formula. In place of x, we have 2x. And when x tend to 0, 2x will tend to 0. Okay, next problem, guys. The third problem now. Give it a try, guys. Limit x tend to 0, a power x minus b power x by x. Give it a try. Let us start discussion. So answer for this problem is ln a by b. What you can do here, just add and subtract 1 and then split them. You get a power x minus 1 by x minus b power x minus 1 by x. So this will be ln a, this will be ln b. So ln a minus ln b will be ln a by b. I hope it is clear, guys. Next problem. The fourth problem we have limit x tend to 0, 10 power x minus 2 power x minus 5 power x plus 1 by 1 minus cos x. It's a good problem, guys. Give it a try. Let us start discussion. So the answer for this problem is 2 times ln 2 ln 5. What do we do here, guys? See, this is in the form, the numerator is like AB minus A minus B plus 1. 10 power x is nothing but product of 2 power x and 5 power x. So if we have AB minus A minus B plus 1, in the first two terms, if you take A common, you get B minus 1. Next, you take minus 1 common, you get B minus 1. So this will be factorized as A minus 1 into B minus 1. So numerator we can write as 2 power x minus 1 into 5 power x minus 1. Each of them would need x, so we multiply divide by x square, and this x you can break in the denominator. So this will become ln 2, this will become ln 5, and 1 minus cos x by x square is supposed to be 1 by 2 in the denominator, so it will become 2. So final answer is ln 2 ln 5 into 2. I hope it is clear, guys. Next problem. Next we have limit x tend to pi by 2 a power cot x minus a power cos x by cot x minus cos x. When you are doing these problems, do not use LH rule. Try to use by rearrangement only. If you try to use blindly LH rule in every problem, you won't learn how to solve typical problems. Because when the question will get more typical, LH will not be a feasible method. So always learn these rearrangement techniques which we are using here. So try this problem. Let us start discussion now. See, I take a power cos x common here because if I take a power cos x common in the numerator, you get a power cot x minus cos x minus 1. In the denominator also we have cot x minus cos x. If I put x as pi by 2, cot x minus cos x will tend to 0. So become a power fx minus 1 by fx. When fx tend to 0, it will just be ln a. And a power cos x, if you put pi by 2 here, you get a power 0, which will just be 1. So final answer is just ln a. I hope it is clear, guys. Next. Okay, next. Next we have logarithmic limits. I'll just take it, copy it here. See, what do we have here? See, guys, limit x tend to 0 log. Whenever you see log and no base is written, by default base will be e. Okay, so for all of them, if no base is mentioned, by default you assume it to be e. So if we have limit x tend to 0 log 1 plus x by x, it will just be 1. Again, you can prove with the help of LH rule also, or expansion, we'll discuss later. Right now we use directly. Log 1 plus x by x will be 1 when x tend to 0. Similarly, log 1 plus fx. Just give me a moment. Log 1 plus fx by fx will also tend to 1. So limit x tend to 0 log 1 plus x by x is equal to 1. Limit x tend to a log 1 plus fx by fx will also tend to 1. The condition that f of a must be equal to 0. Okay, same thing we'll use in the next one also. Now when the base is a, we have limit x tend to 0 log base a 1 plus x by x. This will become 1 by ln a. And here if we have limit x tend to a, okay, this a will be kind of same thing. So I'll convert this, make this some other, say limit x tend to b. Now we have, so limit x tend to 0, log base a, 1 plus x by x is 1 by ln a, and limit x tend to b, log base a, 1 plus fx by fx. 1 plus fx by fx will also be 1 by ln a. The condition is f of a should be, f of b should be equal to 0. Okay, so same thing here, guys. Log of 1 plus x by x will be 1 when x tend to 0. Log base a 1 plus x by x will be 1 by ln a when x tend to 0. And in place of x, we can f of x. But if x tend to b, f of b should be 0. Okay, now note down this formula, then we'll try some examples. Okay, after writing down this formula, guys, to try the first example, you can pause the video and write down and try. Let us start discussion now. The first example we have limit x tend to 0, a power x minus 1 by log base a 1 plus x. So what do we do here? We say that, I'll just copy it from here. So the answer here will be ln a square. We have a power x minus 1. So multiply divide by x. So you get a power x minus 1 by x will be ln a, and x by log base a 1 plus x. This will also become ln a because it's in the denominator now. So you see the formula was 1 by ln a, but in the denominator it is, so it will become ln a again. So ln a into ln a, directly we get ln a square. So direct formula here. Next problem. Okay, give it a try, guys. Limit x tend to 2 e power x minus 2 minus 1 by log x square minus 3. Pause the video and give it a try. Let us start discussion. So answer for this one is 1 by 4. See how we have limit x tend to 2. So x minus 2 will be 0. So we multiply divide by x minus 2. So we get e power x minus 2 minus 1 by x minus 2. X minus 2 will tend to 0. So this will just become 1. Inside the log, we have x square minus 3. We need 1 plus fx form. So what do we do here? We add and subtract 1. So it will become 1 plus x square minus 4. So in the denominator, we would need x square minus 4, basically in the numerator here. But x minus 2 already we multiplied. So what I can say here is x minus 2 already we multiplied. We multiply 1 x plus 2 also. So we get, so x minus 2 we multiply for e power x minus 2 thing, and then we want x square minus 4, so we multiply x plus 2 also. Multiply divided by x plus 2. Now this, when you multiply together, you get x square minus 4, and when x tend to 2, this thing will be 0. So log 1 plus fx by fx, when fx tend to 0, will just be again 1, and you will be left with only 1 by x plus 2. Here if you put x as 2, you get 1 by 4. So final answer is just 1 by 4. I hope it is clear to guys. Next. Next, we have limit x tend to pi by 4 log tan x by 1 minus cot x. Give it a try, then we'll start discussion. Let us start discussion now. So the answer for this problem is 1. See how. You want log 1 plus fx, but there is only just tan x. So what I'll do is I'll add and subtract 1. So you get log 1 plus tan x minus 1. In the denominator, we have cot x. This you can write as 1 by tan x and take LCM. You finally end up with log 1 plus tan x minus 1 by tan x minus 1 into tan x in the numerator. And when x tend to pi by 4, tan x minus 1 will tend to 0. So log 1 plus fx by fx will become 1 here. Tan x, when you put x as pi by 4, will also become 1 here. So final answer will just be 1. So today, guys, we discuss algebraic limits, trigonometric limits, exponential limits, and logarithmic limits. So that will be all for this class. In the next class, we'll discuss about limits of the form infinity by infinity and more things. Okay, guys, then. Bye-bye.